Hi everyone, welcome to the video on exploring Runway's ML image to video generation API. And this will go through the API and how to use it. Then I will show you how to use it in an iOS app using SwiftUI. We will use a generated image from a URL and also use the photo picker to get the images. So let's get started. I already have access to the Runway ML API. You have to go to the website and ask for the uh, access. I think if I go back to the page on Runway ML, you will see that when you go to research or like on products under API, when you click on get started, it will open a form, Google form that you can fill and get the access to the API. And in the documentation, we have the quick start, which talks about creating a key. I already have a key which I will not reveal. Then you add the credits. I added $10 to get started with, because the video generation, we will look into how much it costs, so you will get an idea on how much seconds that you get from those 10 seconds. And then we use the API. They have an official Node and Python API, but if you're just testing, you can use a curl command as well. For my app, because I'm an iOS developer, I obviously use Swift to get started with. And remember that this, what I'm going to show, is only for quick prototyping. What you will use in a production use case is to have your own proxy server that just sends your prompt to the server, and the server communicates with the Runway API, and then you get back the video and then send it back to your app. So the app has no connection or no API key on the client side. So please keep that in mind and don't sue me if you are broke and out of credits in a few seconds because somebody fished your API key. That's something you need to keep an idea about. So you secure your integration, then monitor the integration. For the billing part, so the Gen 3 turbo model is 5 credits per second, and a credit can be purchased for $0.01 per credit. And the usage, they have some tiers. I'm still on 1 tier because I'm not using that much. And so 5 seconds cost $0.25 and 10 seconds cost 5.5, which means 100 seconds will cost $5, or 200 seconds or roughly 3.5 minutes will cost you 10 credits or $10, not credits. So with that in mind, let's jump into the API itself. So we'll go through the API references and understand how to start generating the video from an image. So there are three kind of API endpoints that they have. The first one is to give image the text prompt, and then it gives you back a task ID that you reference later, and then you hit that endpoint again and again to get the task detail, and then you can either cancel or delete a task as well. So for the first one, you start with the request body, which has the prompt image. This can be a URL that points to the image, or it can also be a base64 encoded image. We will talk about that later. But the first thing to know is that you can use a remote URL image and directly pass it to the prompt image, string URL, then the model name, which is Gen 3 A underscore turbo, then a seed, which is a random value. I usually do not pass this value and let the API use its own value. Then we have the prompt text, which gives the description of how the video should look like. Then you have a default value of watermark if you want to have the runway watermark or not. I don't. Then you have the duration, which is only 5 and 10 right now. In the future, there may be 30 seconds, 60 seconds, we never know. Then we have two ratios, which is a landscape ratio and a portrait ratio. And when you do this request, you get for a successful request, you get back an ID, and then you use that ID to hit the task detail API, in which you just have to pass the ID as the required parameter, and then you get different kind of examples of pending of different type of cases. So the first one is a pending task, which is, as the name suggests, that it is pending, is it is in the queue. And then you have a throttle task. I assume this is when you have been hitting it. I think it's when you have concurrent requests that you have made and it has throttled you. Then after the pending part, it has the running progress, running status, which also gives you a progress value on when the video is being generated. Then finally we have an example of a succeeded task, which outputs the video itself, and an example of a failed task, and then you also get the failure reason and the failure code. You have to make sure that when you hit this API or like pull this API, do not expect updates more than every 5 seconds. So you just hit the API every 5 seconds, and then if you get a succeeded task, you know that you have got an output from it. And finally, you can delete or cancel the task by passing in the ID, and in this you get a 2 or 4 response. You have to do nothing about it. It's the idea is that it's a successful delete or cancel, and if you get any other request, then you know that something has been wrong. So with that in mind, let's jump into the code in Cursor. I have been using this a lot for my iOS development purposes. So what we have here is an image. I'm using async image, and I'm passing in the image with a remote image, which is on street of Shibuya in Tokyo. And we have a photo picker that lets me select an image from the photo library, and then I also have a button for generating the image. And when I look at the code of before, so for the generating image, I pass in the prompt, which is like a dynamic tracking shot. The camera glides through the iconic Shibuya crossing. So while I say all this, I will try to click on generate video because it usually takes some time to generate the video. So the prompt text is dynamic tracking shot. The camera glides through the iconic Shibuya crossing in Tokyo, and capturing a lot of words that I found on Claude. And the wave payment reflects the dazzling lights. Then I take the API key from my environment screen, and then I created my own framework or kind of library for working with it. I will also go through the code so you understand how it actually works. And then I pass this framework with the method on generate prompt, and the response that I get is the task ID, which is like successfully created the task ID. And then I get this poll. I then start polling the status. So in this, we pass in the API key again, and then we try to get the status. Then I switch on the status, which is an enum value. If the case is succeeded, then I get the output URL, the video URL, and then load it on my screen. Otherwise, I would have failed, pending, and when it is pending, throttled, and running, when it is throttled, I would have a 10 seconds delay. When it is pending, I would have a 5 seconds delay. And when it is running, when the task is running, then I would add another 5 seconds delay before it's in a while loop. If you can see, it's while true, and it returns when we succeed. Otherwise it will not return at all. It only returns when I am throwing an error. And find cancel task, I did not implement that, oops. So let's go first watch the video, because that's the exciting part. Oh wow. So you can see how detailed the video is. So in this case, what I can also do, like if you watch the video again, you see that the billboards are also changing in the background, which is something really amazing. Like it's magical to me. So looking at the code, what we have is in this Runway kit is that there is the Runway ML errors. They have different errors that they have mentioned, which starts from the invalid URL, the image too large, or method not allowed. And then we have the different, I added these descriptions for it, then the aspect ratio and the video duration. Then we have the task status. That was the usual Xcode. And then I have a method for generating the image that takes the prompt, the image URL, the duration, aspect ratio, which is very similar to what the API documentation is. I append the path of image to video, add the period token for the header field of authorization, the content type as JSON, and we are required to add this X runway version for 13th of September as the header as well. And then in the body, I add the prompt image and everything and convert it into data and add it to the request. After making the request, if the data has an ID, I return back the ID, otherwise I throw the error that we got. And it is the second thing which is important is this generate image. So what we do is I have this method called as image to base64 string generation, where it takes a runway image. Runway image is a type alias for an UI image when it is on Vision OS, iOS and tvOS, and it is an NS image on macOS. So it takes the representation of the image and converts it into using JPEG data. It converts it into data and then takes that data and converts into a base encoded 64 string. And you also have to know that the image size should not exceed 3 MB limit. Right now I have not handled this case where it can, if it is more than 3 MB, then it will like try to compress the audio so that it's much nicer. But that's one thing I have to do. And otherwise it gives back the base64 string. And then after that the process is just normal, that we have to add this one thing that I missed, which is we have to add this data URI, that the data is image of type JPEG and it is of the base 64 encoding, and then you use the same URL or the method that I had before for generating the image based on the prompt and the image URL. And then we have the method on getting the task details. We have the same headers, and then when we hit that endpoint, we decode the data. If it is a 200 case, then we get the task response and handle the task response based on what the task response is. If it is pending, return that, and if it is a progress, we give it the progress back. If it is the output, I send back the URL, and then we have the cancel or delete method. So let's try it for the image where we have it from a photo picker. So I have this futuristic cars that are going through, which looks really cool. It is something that I created in a live stream with my friend Ray. And then when I click on generate image, it starts generating. So what I have realized is that it is usually pending for 30 seconds to almost a minute, and after that it would take around maybe 5 to 10 seconds to run, or maybe less, and then we get the succeeded output URL. So while it does this while it does the progressing or the progress view, I have to say something so I can fill in the seconds. So working on this was fun. I enjoyed doing that. Most of the code for this runway kit that I've used is written by Cursor itself. I have not written much of it, and I mostly updated it for my style, and that's it. And I love this new way of programming because I enjoy the outcome of programming more than the journey itself. So I can just give it the documentation and ask it to generate a whole reference for me, because I could not find an open API spec file for the Runway ML API. So we have the video generated, and let's have a look at it. That's cool. I feel like I have a skill issue when it comes to generating the videos. And one thing before I end this video is that they have some really good documentation on the prompting guide, and let's see if I can find it on the website itself. So I finally found the link, and it is the Gen 3 Alpha prompting guide, where it helps you understand how to work with the text only based prompts that you have. And you have to start in a consistent way where you have the camera moment, then the establishing scene, and the additional details, and use this structure uh, for most of the cases that you have. And then when you're using the image to text, you can focus on describing the moments rather than the contents of the image. It's on your thing. The thing is that it's a bit expensive, not a bit expensive, but you have to play it. It's not as cheap as generating images or text based thing. Like if you're using Flux, which is now free, if you're using Together AI versus this, where you have to like spend for 20 seconds video, you're spending $1. So it's a trade-off that you have to make sure that you're happy with. So for the prompt keywords, you have the camera style from low angle, high angle, so many of them, so many. And you have the lightning styles that you want. Oh my god. And the moment speed from dynamic motion, I think this is the coolest one. Then the fast motion, a time lapse as well. And the moment types, that it grows, emerges, explodes, wraps, so much to do. Moody, cinematic. I'm more excited about the future when the prices go down more, and that's why I'm invested in creating more of these videos. So when the prices go down and this is as cheap as like creating a Hollywood movie level thing is $100 or $200, that's what I'm looking forward to. And with that, I end this video, and I hope you learned something new and would want to try it out yourself. Have a good day.